Thank you for trying Qweebi, and welcome to your teacher dashboard. In the next few minutes, you'll be able to clearly see how you can run Qweebi in your classroom. All it takes is 4 easy steps. Pick a project, prep for it, run it in your class, and assess student work. Let's take a look. Step 1 is to pick your first project. Head over to our project library page. Feel free to browse through project details and teacher resources before deciding which project you'd like to run in your classroom. Now that you've picked a project, step 2 is to prep for your project before class. Prepping for a project should take you about 30 minutes. First, review the teacher slides that come with every project, and then open up the Qweebi Makerspace and try the build for yourself. Okay, so you've picked a project, and you've also prepped for it. Step 3 is to run that project in your class. Running a Qweebi project in class always starts with an engaging hook. It's an exciting video that gets your students fired up about solving that engineering challenge. When it's time to build, your students will open up the Qweebi Makerspace, find all the supplies they need, and start building right away, just like that. With all your students deeply engaged in their builds, you can focus on walking around the room and helping them test and refine their prototypes. Once your students have finished the build, there's a really fun way for them to share their work. On Qweebi, students can quickly record a show and tell video explaining everything they've built. After running a project in class, step 4 is to assess student work. It's really simple, and we think you'll really enjoy assessments on Qweebi. All show and tell videos that your students submit are available to you on one place, right on your teacher dashboard. You can watch videos, leave feedback, and even grade their work with built-in rubrics. Next, let's take a look at a student show and tell video.
Hi, my name is Alessandra DeFazio. I named my rover Lightning Dash. It weighs 117.50 grams and has 2 propellers that produce 372.28 newtons. It has 8 wheels and 4 axles. For this science vessel rover, I first tried a smaller cardboard box with only 2 axles and 4 wheels, and it didn't work when crossing the Mars surface. Finally, I tried 4 boxes with 8 wheels, 4 axles, and 2 propellers, and it worked, going over all the bumps to the finish line. The average speed was 3.78 kilometers per hour, and it took around 13 seconds to finish. I learned that the bigger base and more wheels there are, the better it will get over all the bumps and not flip over. I most enjoyed the process of building my rover. I'll now test my rover. Thank you.